Okay, yesterday we talked about there being two reasons why an integral was improper. One was that one of your limits was infinity or negative infinity. The other is that if an asymptote is involved at one of your limits of integration or in the middle of a limit of integration. So we're going to talk, and we didn't talk about the asymptotes yesterday. We just talked about the limits being infinity. All right, so if f is continuous between a and b and has an infinite discontinuity at b, an infinite discontinuity is a fancy name for a vertical asymptote. So this function has a vertical asymptote at b. Then if we're trying to integrate between a and b, where b is a vertical asymptote, then what we're going to have to do is we're going to have to take the limit as c approaches b from the left side, integral from a to c. Okay, and that kind of makes sense. So let's say that you've got, if you think about it graphically, let's say that you've got some function and you have a vertical asymptote at x equal 2. And I don't know what this function looks like. It looks something like this. And then let's say that this is 1. So if I wanted to integrate from 1 to 2, then that integral is butting up against that vertical asymptote at x equal 2. So I'm going to have to take the limit as c approaches 2, but is my graph approaching 2 from the left side or from the right side? From the left side. So that's why it's 2 from the left, integral from 1 to c of f of x. It won't always be from the left, because let's say that your vertical asymptote is your lower limit of integration. Okay, so let's say that we were wanting to integrate from, say, 2 to 3. Then the improper part of this is the 2, so I'm going to have to take the limit as c approaches 2, but this graph is approaching 2, or that asymptote, from which side? The right side. If your vertical asymptote is on the right of your graph, or the top limit of integration, we'll take the limit as x approaches that asymptote from the left side. But if your asymptote is on the left side of that graph, meaning it's on the bottom limit, then we'll take the limit as x approaches that number from the right side. And it just kind of takes, I don't really have that memorized where I can spout it off quickly. It just kind of takes memorizing or being able to visualize what side that asymptote is on. Okay, and then if we have an asymptote that's in the very middle of the interval between a and b, then we're going to have to integrate from a to c and then from c to b. And I will show you examples of all of these. And these are a little bit trickier because they're not as obvious that they're improper integrals. You have to pay really close attention because it could just look like one of the other ones that I've given you in the past. But if we have 1 over the cubed root of x, is there a vertical asymptote in that graph? Yes, and where is it? 0, and it's part of one of those limits. So if I'm integrating from 0 to 1, is that vertical asymptote on the left side or the right side of my graph? It's on the left side of the graph, so the graph will be approaching that asymptote from the right side. So I'm going to it doesn't matter what the graph of 1 over the cubed root of x looks like. It's just that you have a vertical asymptote at x equals 0. And then we're going to integrate between 0 and 1. And this graph is somewhere in between those two. So the graph is going towards that asymptote from the right side. So I'm going to take the limit as c approaches 0 from the right side, integral from c to 1. And since I'm integrating, I'm going to rewrite this as x to the negative 1/3. Okay, what do you get when you integrate x to the negative 1/3? Okay, 3/2 x to the 2/3, evaluated from c to 1, and that's still the limit as c approaches 0 from the right. Okay, so plug in my 1 for x, and I get 3/2, minus plug in my c, and I get 3/2 c to the 2/3. Okay, so as c approaches 0, what does 3/2 c to the 2/3 approach? 0. So 3/2 minus 0 is 3/2. Probably the hardest part of the ones that involve asymptotes is just figuring out whether or not you're supposed to write the limit as x approaches that value from the left side or from the right side. It doesn't really make a difference about actually evaluating the limit as to whether or not you do the plus or the minus, but so much about this process is about the notation, and when they test you on this on the AP exam, they're going to put all the points in the notation part. So they're going to give you a point for like this right here, that very first thing that I wrote, and if you had 0 from the left side, you'd lose that point. Now, that's not to mean that you couldn't work through and get the answer point, but it's all about the notation. Okay, number 2. Where's your asymptote on number 2? At 0, once again. And this time, we're integrating between 0 and 2. And who knows what that graph looks like? I mean, it could look something like this. But I know that as that graph approaches 0, it's approaching that asymptote. It could be going down. It could be going up. But the bottom line is that as that graph approaches that asymptote, it's approaching from the right side. So I need to take the limit as x approaches c, once again from the right side. Integral from c to 2, x to the negative 3. So limit as x approaches c from the right. Integral of x to the negative 3. Yeah, because I'm confused. So it's the limit as c approaches 0 from the right. Okay, so what's the integral of x to the negative 3? Okay. Okay, limit as c approaches 0 from the right. Plug in my 2. I'm going to get negative 1/2 times 1/4. Minus negative 1/2 c to the negative 2, or plus 1/2 c to the negative 2, or I could bring that c down to the bottom. Negative 1/2 times negative 1/4 is negative 1/8. Plus 1 over a tiny, 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 tiny number, which is infinity. And negative 1/8 plus infinity is still going to be infinity, so this integral diverges. because as x approaches 0, your denominator is getting smaller and smaller and smaller. Like 2 times a c squared. Like 2c squared as c goes to 0 is going to get smaller and smaller and smaller. So you've got 1 divided by a really small number, or think about it as like 1 divided by 1/10. That's going to equal 10. And then as c gets closer to 0, you would get like 1 over 1/100th, which is 100. So if your bottom of your fraction is getting smaller and smaller and smaller, 1 divided by that's going to get bigger and bigger and bigger.